Ollie, good to see you again. I'm trying to
Good to
think
see
of
you,
the
Pete.
last time we saw each other in person. I don't remember.
Um,
It's been kind of a whirlwind.
it's been
California,
busy.
maybe? I don't know.
Yeah, I think it was California. I think it was one of the event, or maybe Taiwan.
Maybe Taiwan.
We
Yeah,
were we
that's
were
true.
together in Taiwan. Yeah,
That is true. Yes, Taipei. Well, good to see you again, and cool background once again.
thank you.
Nice. Uh, this is all about introducing partners to the ecosystem, and kind of the diversity of partners in our stack for the Edji Foundation, which is pretty cool. That being said, most people know who NXP is, but if you can kind of let us know, you're head of AI strategy and technologies at NXP, and have been a longtime supporter of the foundation. So I appreciate you coming this morning to talk. Maybe you can give us a little bit of. I'm not going to ask you for the origin story of NXP because that would probably take the whole time. But in terms of the entree of NXP into the AI space, I mean, you guys kind of got into this a number of years ago, right? This isn't
Yeah.
sort of a recent development for you, right?
It's. I mean, my joining NXP is about 10 years now, and we came in with an AI story from the startup that I was with that got acquired. So NXP's been in the whole AI space for quite some time. Let's say in one of the early edge AI silicon vendors out
Right.
there, and more recent history. I mean, we're fundamentally a semiconductor processor vendor. A lot of
Right.
semiconductor for various markets. We play heavily in automotive, but also in industrial and IoT
Hmm.
markets as well.
Hmm.
And we provide a lot of processing solutions and SoCs and chips into those markets, as well as PMICs and other sensor and analog components as well. But our main part of what I mostly focus on is the AI hardware and software enablement that we put into our processor devices, and that's a wide portfolio starting from the traditional microcontrollers, devices that have like Cortex M cores running real-time OS and 100, 150 megahertz type of clock range on the CPU, and then
Mm.
scaling into more and more capable micros into applications processors with our i.MX lineup, which is now in its ninth generation. So we have i.MX 9
Right.
applications device processors out there, and what we're very focused on is, and we're seeing a demand in the market. That's why we're responding to it and building towards it. Is we're adding dedicated AI acceleration across that whole portfolio. So we have
Mm.
devices in the traditional MCU space, 150 megahertz, you know, um, CPU, the Cortex M33 with an accelerator
Hmm.
beside it. Or you have a slightly larger micro with a with more capable DSPs with 2D GPUs, etc. Again, with a dedicated accelerator in our i.MX RT700.
Mm.
And then you get into the i.MX applications processors. These are the Linux capable multi-core Cortex A, Cortex M mixed SoC with very rich GPU, DSP, and I/O options. And again, like we started 3-4 years back in that family with the i.MX 8M Plus to
Hmm.
add a dedicated accelerator, and now a lot of that portfolio has some amount of dedicated AI acceleration. There is an NPU in pretty much every device coming out in that family now,
Mm.
currently. So, and of course, that means that you got to build the software so that our developers can leverage it, and that's where we're putting a lot of emphasis, trying to I like saying that we're not trying to make AI easy. We're just trying to make it easier with that
Yeah.
software enablement, because
Right.
it's not easy. Trying to
Right.
take it from server grade, cloud grade down into the edge. It's just about trying to make that transition smoother and add a lot more value on that edge.
Yeah. And you're one of the few semiconductor companies that's really going from kind of edge to cloud. I mean, you're like you mentioned, the portfolio is quite broad.
Mhm.
And so how do you see that sort of connection? You mentioned about kind of going from the cloud to edge. I'm sort of somewhat familiar with that coming from Microsoft. And there's like frameworks like Onyx and things like that. I mean, do you see that there's a lot more, when you think about these deployed solutions that are using AI, like what is the connection to the cloud, or how do you think the cloud could be better leveraged?
I mean, from our perspective, where NXP plays is on edge inference. I mean, we don't really get into the training side of things. We think there's better devices and a lot more compute available on the cloud or on-prem servers for doing the typical ML training or AI training. And then we play more on the inference side, and even within that inference um, side, our portfolio is more suitable for true edge deployments. It's not, inference on a server grade type of device. It's inference on devices themselves, on the anything that's deployed in a vehicle, anything that's deployed in a smart home, smart building, smart factory makes more sense for our portfolio. But that's not to say that we are edge versus cloud. And sometimes people mistake that you're either on the edge or you're on the cloud. But it seems like I've lost you on the audio side here.
There you go. I'm back. Sorry about that. Boy, today's bad internet day. Anyway,
did the recording keep going, or that
it
was?
sort of did, then it died. I think you were at we were talking about cloud to edge and what's the connection.
I can take it back. Yeah.
Okay.
I can take it back to so we approach it as our portfolio plays mostly on the inference side of the AI story, not on the training. Of course, we do support a certain amount of on-device training and edge training capabilities where it's necessary, but a lot of training usually is done on higher compute with higher resource memory availability and compute availability. Even on the inference side of things, we're more focused on edge inference or true edge inference. We're running on the devices. You're running on resource restricted, both power or connectivity restricted devices, potentially on smart home, smart factory, smart building type of deployments, or even vehicle deployments. But we don't take an approach of edge versus cloud, that one is better than the other. A lot of times, edge deployments are about saving costs or creating higher security and privacy, meeting those higher requirements around security and privacy, or reducing costs around connectivity and deployment. And while achieving that, if you still have connectivity, that gives you a better potential for doing your ML ops perspective. Like, you can maintain your models better, you can actually collect data from the edge and improve your overall model. So it's that hybrid approach of, it's not edge versus cloud, is edge can be better with cloud, and the cloud, moving from the cloud to the edge, does have a lot of benefits to the end use cases typically. And that's what we're trying to make sure that we have a portfolio that meets the needs as more and more of these workloads are moving to the edge devices and the edge processors.
Right. No, that makes sense. And are you seeing any, especially for the more MPU class things that you were talking about, are you seeing any whispers or beginnings of generative, like transformer-based models, VLMs, and things like that?
Definitely. I mean, so we're already supporting those with our existing portfolio of devices. On the current higher end, that we have a device called the iDatum X95, and there we've deployed generative AI models, LLMs and VLMs. Typically, they're sub 8 billion parameter size,
Right.
because you do still with LLMs, the dynamic has kind of shifted a bit. It's no longer compute restriction. It's more about memory restriction that we see, and access rate restrictions that we see. So it's still holding right now that there's a bit of a rough calculation that for each billion parameters that you have in an LLM, you need to account for about a gigabyte of DDR memory. So if you have 8 gigabytes of DDR, you're not going to run more than 7-8 billion parameters. And even then, you need to be cognizant of your token time to first token and token generation rates. So we've built out enablement in terms of what we call EIQ Gen AI flow. So it's more of a methodology than a pure compiler or SDK type of tool, where we're seeing also a shift in how our developers and users are using generative AI models themselves. So with CNNs, when we were doing when the workload and this is still predominantly the market, by the way, for us. When people are doing vision AI models and solution creation with convolutional neural network models, they tend to maybe start with a model or use a model as a benchmark, but they typically do customize. They retrain. They do some level of customization. They'll take a model off the shelf, like a YOLO V5, V8, and then heavily modify that so it becomes more of a custom model. They'll take a mobile net and create a variant of it. And the barrier to that type of customization is not very high in CNNs, but with LLMs, it is quite high. So if you try to actually train or retrain an LLM, a multi-billion parameter model, you do need quite a bit of expertise in that domain. It is a more scarce resource in terms of the people that know how to do it. You need a lot more compute. You need a lot more data, and a means to curate that data. So we're seeing the shift more from taking a model, using it as a starting point, customizing it heavily, and then deploying with a custom model in the market, versus with LLMs, it's more about reusing a state-of-the-art known open source model or a state-of-the-art known model with minimal retraining, or even using methodologies like retrieval augmented generation, RAG, to do post-training context awareness to that model, because we can't, in the markets that we're active in, industrial, automotive, medical, you can't have your LLM hallucinate about results. So when you're using it, it has to be fact-based responses. So we're seeing this being deployed starting with conversational HMIs, so human machine interfaces, in all of these markets, in like automotive e-cockpits, in medical device interactions, both with the medical practitioner, or maybe the patient, or the service receiver, as well as in industrial settings and smart factories with operators and machinery. So you're having this conversational HMI potential to more easily work with the device without needing specific keywords or specific commands. And that's one of the first applications that is going to market that we're seeing on our devices with this technology. So LLMs. And then we're also seeing deployment of vision language models, so multimodal or VLM type of models getting used in scene understanding, and being deployed very quickly into actual use cases.
Right. Yeah, no, it's fascinating. I mean, I think it's becoming it's definitely a hot topic. People are talking about, mentioned about HMI and where's the right fit. Excuse me. Where's the right fit for generative AI in the edge? And so we're starting to see some of those use cases pop up. You guys seem to be on the
I mean, it all
cutting
started
edge.
off. It all started off, and if there were demos of image generation, etc. And that doesn't make sense in a lot of the markets that we're in. But when you get into, like I said, conversational HMIs or scene understanding, situation awareness, deploying smart, not surveillance, but smart monitoring systems for health and safety in a factory or industrial setting, that's getting quickly deployed now.
Yeah. Well, providing context around a lot of sensor data and a lot of, that can really help the human operator really understand what's going on. So that's pretty cool. So, so NXP is a worldwide company. I mean, so you're based in Canada, right?
I'm based in Ottawa, Canada.
Yeah, cool.
Part of a smaller office that we have up here, about 50 people, but we, like you said, we have a very large global presence.
Yeah. So is the AI, I've met with a lot of companies. They sort of, AI is sort of like almost like a virtual product line across many different geographies. And I mean, how do you think about it at NXP? Do you have sort of a center of excellence for AI that kind of works across groups, or how's that?
We have multiple formations. So we have multiple business lines. Where we have the business line that I'm officially part of, called Secure Connected Edge. This is where we have our i.MX products. We have a business line that is Advanced Automotive, analog and automotive systems, that is more towards devices that go into the chassis of vehicles, etc. So we have these two main business lines, and both of them are very active in AI. So we do have both product innovation and software and hardware groups that service those two businesses.
Right.
And then we do have a centralized CTO organization with a AI center of competence as well that kind of works on very collaboratively with the business lines that I'm also part of leading our innovation board in that context that touches to the AI competence center that we run.
Right.
So and we're very distributed globally. It's I mean, talent is distributed. We're distributed as well in terms of both where the AI innovation happens, but as well as the actual R&D happens as well.
Right. And then, yeah, speaking of organization, so NXP acquired Canara recently.
We're not done yet.
Not done yet.
We're still waiting for regulatory approvals, but yeah, we've announced it, and we're working very hard to make sure that it happens
Okay.
in the first half this year. Yeah.
Cool. Well, we'll have to circle back on that once the transaction closes. But yeah, no, I think it's fascinating space, and we're seeing so many. We have a lot of startups in the foundation too, and a lot of companies that are kind of finding their niche in that stack. From metal to cloud, and it certainly is. We're seeing some interesting sort of vertical integration.
Definitely. I mean,
Companies to that stuff.
for us, the Canara acquisition, it's really very, very complementary to what we had in the portfolio that I also described. So getting into microcontrollers up to applications processors, we've had good success with our customers with the integrated native AI compute capacity that we were offering.
Sure.
But then, some customers need more.
hmm
There's always somebody that needs it more than what you have, and
Right.
that was already, even prior to the acquisition announcement, part of our scaling strategy of having options with external dedicated NPUs, dedicated AI accelerators, to complement the product portfolio. And then
Yeah.
we came at a point where Canara had good technology and good penetration in terms of, especially their capabilities with LLMs and generative AI use cases. So it just felt again that it accelerated NXP's timeline quite well in bringing that into the fold, provided that
Right.
we complete that acquisition.
Yeah.
And so it scales and becomes, and then the challenge shifts very quickly from two companies with two devices kind of connecting over PCIe or USB,
Right.
etc., to also integrating at the software level, which is
Sure.
the big challenge that
Sure.
we're right away trying
Well,
to engage in.
NXP, as the corporate history of NXP, is around a lot of kind of merging of companies together, right? Philips and Freescale and so
Yeah, I
that's
mean,
kind of where we're
NXP is a spin-off of Philips.
right.
Freescale was a spin-off of Motorola, the semiconductor entities for both of those companies, and then the acquisition of Freescale by NXP that kind of brought it all together. This in around the
Yeah.
2015 timeframe.
Yeah.
So two very big fabless semi companies coming
Right.
together, and then we've announced a few acquisitions this year, and Canara is directly in the AI field in
Yeah.
that
Cool.
aspect.
And I think just before we wrap up, just want to say thank you for NXP's support of the Edji Foundation. I know that you guys are deeply involved. You have, people know Davis Sawyer. He's
Mhm.
kind of famous for our live streams and involved in our blueprints working group, and Adam Fuchs in our data sets working group. And so you guys have really leaned in to help kind of provide leadership in the community too, which I think is really important, because this is definitely, I mean, as you sort of inferred, this is a team sport in terms of collaboration and getting real solutions out into customers' hands. So I think it's important to have that kind of support.
Exactly. Yeah, definitely. We're very happy with our contributions and the collaboration that we have with the Edge AI Foundation, and also in the last year, the shift from what used to be TinyML towards Edge AI also aligns very well with our portfolio.
Right.
It kind of felt like we had to only talk about half our technology when we were trying to say, like, what is tiny and what isn't. But under the Edge AI Foundation banner, with the expanded focus that the foundation has, it's very complementary to our position in the market, and we feel like that's why, like you mentioned, I have colleagues that are very active in the foundation work with the work groups, with the content, and yeah, we're looking forward to building more and more, and working together with all the partners in the foundation, but with the foundation directly as well.
Cool. No, really appreciate it. Well, Ollie, thanks for your time this morning. Hopefully, you're doing well there in Ottawa. I'm here in Bellevue, Washington. I'm sure we will meet again in one of these things, the way it works. But yeah, thanks a lot for your time.
Look forward to it. Thanks, Pete.
Cool. Take care.
Bye.